right, guys, so today we are going to talk about solving multi-step equations. So to solve multi-step equations, use inverse operations to isolate the variable. And this is just like what we did in 1.1. If you hear some background noise today, my son, I picked him up early from school, so he is in the background. So you might hear some noises in the background. I do apologize if he makes any. But again, when we're solving multi-step equations, we're going to use inverse operations to isolate that variable, just like we did in that previous section. So in example 1, we're going to look at solving a two-step equation So for this example, it says the height in feet of a tree after X years is 1.5x plus 15 after how many years is the tree (24 feet tall? So I have 1.5x plus 15 equals 24. Now, if you remember back to what we did in 1.1, it gave us either x plus 15 equal to a number or 1.5x equal to a number. This is called multi-step equations because we're now doing both of those things at the same time. So we have to do essentially the opposite of those order of operations, and we're going to undo our addition or subtraction first. So I'm going to subtract 15 from both sides here, and that's going to give me 1.5x equals 9. And then I'm going to divide both sides by that 1.5, and that's going to give me x is equal to 6. Yes, before you ask, I'm sure there's lots of eye rolls going on because you know it's coming. We also have to show the check. First step of the check is to write the original equation, followed by a semicolon and what you think the variable is equal to. We're then going to substitute that in. And we proved that left side is equal to the right side mathematically. So we're finished with example 1. So that's just a basic example of a two-step equation. So now they're going to add in an extra step before we can follow that solving. We'll go for that solution. So example 2 has us combining like terms to solve an equation. So this one says solve 8x minus 6x minus 25 equals negative 35. So remember, my first step is to always rewrite my equation. So 8x minus 6x minus 25 equals negative 35. And again, it's having us combine like terms. So I'm going to combine those like terms. 8x minus 6x, or 8x plus negative 6x, is going to give me 2x. So now I have 2x minus 25 equals negative 35. Now it looks more like what we did in example 1. So again, I'm going to add or subtract first. They give me subtraction, so the inverse is addition. So I'm going to add 25 to both sides. That's going to leave me with 2x, because your negative 25 and your positive 25 are going to cancel. And then negative 35 plus positive 25 is going to give me a negative 10. Now I have to show that I'm dividing both sides by 2. And I'm going to get x is equal to negative 5. From here, you know what's coming next. I'm going to check by writing my original equation. 8x minus 6x minus 25 equals negative 35, semicolon. We think x is equal to negative 5. My next step is to substitute that in for all of those x variables. So I have 8 times negative 5 minus 6 times negative 5 minus 25 equals negative 35. Okay. 8 times negative 5 is negative 40. Negative 6 times negative 5 is positive 30. And minus 25 equals negative 35. Combining like terms, I'm just going left to right at this point. So negative 40 plus 30 is negative 10. Minus 25 equals negative 35. Now I'm going to combine these. Negative 10 minus 25, or negative 10 plus negative 25 is negative 35. So I have proven that my left side is equal to my right side, which in fact gives me that check. All right, let's flip over to the back. So for 3, another fun thing they're having us doing. So again, they're adding an extra process in, or an extra step in here. So now we're going to be using the distributive property. To solve an equation. Okay, so now it says to solve 2, and then it has parentheses 1 minus 5x plus 4 equal to negative 8. So as always, our first thing is to always rewrite the problem. So I have 2 times the difference of 1 minus 5x plus 4 equal to negative 8. So again, now I have to, and it tells me what I'm doing in my heading here. It says I'm using the distributive property. So this 2 is going to get distributed to the 1 as well as that 5x there, or negative 5x if you want to think of it as having the sign in front of it. So 2 times 1 is 2. 2 times negative 5 is negative 10. So it's 2 times negative 5x would give me negative 10x plus 4 equals negative 8. Now I have to go back and do what we did in the previous example, which was combining like terms. So my like terms here are the 2 and the 4, both being positive. And then I have a negative 10x here. All right, so that's going to give me negative 10x plus 6 equals negative 8 after I combine like terms. I don't know what you're saying. What about him? You gave him food and water. Thank you. All right, so back to example 1. Now I have to add or subtract to get my variable term by itself. They give me a plus 6, so I'm going to subtract 6 from both sides. Bring down my negative 10x. Negative 8 plus negative 6 is negative 14. Divide both sides by negative 10. And x is equal to positive 1.4. So if you remember how I talked about them adding a step each time. So the first time we just had to add or subtract and then multiply or divide. And the next time we had to combine like terms. From there, we added distributive property. So all of those are kind of fair game at this point. Okay, so before we're finished with this one, we have to, yep, your favorite part, check it. Writing the original equation, so I have 2 times the difference of 1 minus 5x plus 4 equals negative 8, semicolon, x equals 1.4. So now I'm going to substitute that in. So 2 times the difference of 1 minus 5 times 1.4 plus 4 equals negative 8. So I have to do what's in my parentheses first. Within the parentheses, I have to do this multiplication first. So I'm going to bring down my 2 and my 1. Negative 5 times 1.4 is going to give me negative 7. And I bring down my plus 4 equals negative 8. So, parentheses first. So I get 2 times negative 6 plus 4 equals negative 8. How did I get negative 6? 1 plus negative 7 is negative 6. Now I have to multiply, and I get negative 12. Bring down my plus 4 equals negative 8. Please stop shaking the table. Negative 12 plus 4 is negative 8. So I have proven that negative 8 is equal to negative 8. All right, our last one. This is real life application. So it says in example 4, use the table to find the number of miles X you need to run on Friday so that the mean number of miles run per day is 1.5. First thing we should remember is that the mean means average, right? So your mean is your average. Okay. So we're going to look at our day and our miles. So I've got Monday, Tuesday, Wednesday, Thursday, Friday. I don't know why I use an R, but I use an R for Thursday. So Monday it says we did 2 miles, Tuesday none, Wednesday 1.5, Thursday none, and Friday is our X. So that's the information given to us. So in order to find an average, I have to add all of these up and divide by however many there are. So I'm going to get 2 plus 0 plus 1.5 plus 0 plus X divided by 5. That's going to give me the average. But we said I wanted it equal to 1.5. So now I have to combine like terms. So I have 1x. You always want to put that variable term first. Then I have my constants. 2 plus 1.5 is 3.5. Don't forget that that is all over 5. So the first thing I'm going to do is try to get rid of that 5 on the bottom. So I'm going to multiply both sides by 5. That is going to give me 3.5, or sorry, x plus 3.5 equals 7.5. I'm going to subtract 3.5 from both sides to find that x equals 4, which means you need to run 4 miles on Friday. I'll be nice and not make you do a check for 4. But I don't know if you noticed this, but when we went over this side, I left a little space here. And that's because I want to go through with you and put in here almost like a little cheat sheet of what we're going to do. So this is for all of them. So it's not just looking at example 1, example 2, example 3. This is just kind of in general, okay? So in general, the first thing you're going to do is rewrite it. So you're going to write it down, right? Then your next step is actually from example 3, distribute if needed. Okay. Following that, then you're going to combine like terms. And this is again, if needed. Then you're going to add or subtract. And then finally you're going to multiply, or divide. Okay, so that's kind of like your little cheat sheet of what's going to happen. So you're going to rewrite your equation. If you need to distribute anything, you do that first. Then you combine like terms if you need to. Then you're going to add or subtract, and then you're going to multiply or divide. And that is the basic gist of solving multi-step equations.